Okay, guys, we got one section of notes to go. Thanks for sticking with me. And this section of notes should be easy because we're going to revisit a concept that we've already referenced once before. This section is about studying variation and natural selection. So let me ask you a question. Like, generally speaking, humans are humans, right? We've got 2 hands, we've got 2 feet, we got 2 eyes, 2 ears, we walk upright. We've got the ability to reason. So there's a lot of similarities between us. But within the human population, are there variations? Like, are there different versions of humans? And if so, what are some of the variations between us? What are some of the characteristics that make you and I different from each other? Yeah, it's kind of obvious, right? Some of us grow to be really, really tall, and some of us always stay short. Some of us lose our flippin' rippin' hair. Some of us have more athletic ability than others. Some of us have different skin tones and skin shades. Even within an individual race, somebody can be light-skinned versus dark-skinned, right? Those are all variations within the human population. And you and I have inherited those variations from our parents. That's where they come from. You look the most similar to your mom and dad, and you don't look very similar to me. It's probably a good thing. You're lucky, right? Well, those are variations in our body structures and in our characteristics, and we call those things phenotypes. You actually learned about those in 7th grade. Okay, a phenotype is an organism's body structures or characteristics. And they're not universal across the population. Not all humans have the same body structures and characteristics. Not all frogs have the same body structures and characteristics. Not all daffodils or daisies have the same body structures or characteristics. There's variation within every population. Now, sometimes those variations become really important because they help an organism to better find or obtain resources, or because they help an organism to better reproduce. So when a phenotype, a structure, or a function of an organism, when it helps that organism to better survive, thrive, and reproduce, then it's going to pass that positive variation down to its offspring. Here's a population of butterflies, right? And if you take a look at those butterflies, they're not the same. There are differences in those butterflies. Some of those differences are big and obvious. Some of those differences are small and not so obvious. But those are variations. Those are genetic mutations that have been inherited by each of the individual generations of butterfly. Now, if any of those variations help the butterfly to survive or thrive or reproduce, then that variation is going to be passed down to its offspring. And if any of those variations, if those differences in phenotypes are unhelpful, if they don't help the butterfly to survive and reproduce, then that particular phenotype, that physical characteristic, isn't going to be passed down to offspring, and it will eventually disappear. I'll give you an example. I noticed that this guy over here has really obvious white marks on its wings, and it's got really obvious white marks down in between its wings, right? This guy over here has less obvious wing marks, and there's no white separating its wings. If this stripe of white serves any purpose at helping this critter to survive, thrive, or reproduce, then that trait is going to be passed down to its offspring. I'll give you an example. Maybe this extra little white stripe is really attractive to the other butterflies. Maybe other butterflies go, "Oh, wow, check that guy out." Well, that's going to help him to reproduce, and he will pass that positive trait on. Or maybe these big white splotches like mirror the eyes of an owl or the eyes of a predator bird. And as a result, other things aren't going to come and eat it. Cricket isn't going to attack a giant hawk. So if he thinks that these white marks are the eyes of a hawk, maybe he'll avoid this butterfly. That butterfly will survive and then reproduce, passing its traits on. Where does this all start from? It starts from variations, differences in the phenotypes within the same population. Some of those differences are helpful. They might help the creature to survive in new environmental conditions. Some of them may be helpful. They may help the creature to reproduce at higher rates. And if those variations are helpful, then they end up getting passed down to offspring. As a creature reproduces, it passes its helpful traits on. You get that, right? And if a creature has an unhelpful variation, ain't going to be around long. It's going to die, and it's not going to pass that trait on. We call those helpful traits, we call them favored traits. And what we're really saying is, in some ways, nature is choosing the phenotypes that work the best. Now, that's where the natural selection part comes in, right? Nature is choosing the traits that are the most favorable. And there's not really an active choice going on. It's not like there's a mother nature somewhere saying, this is the trait that is going to be the positive trait because I like it. What's really happening is those favored traits allow the organism to survive and thrive and reproduce. It allows the organism to adapt to the habitat, which means it's more likely to survive, which means it's more likely to reproduce, which means it's going to pass its phenotype, its body characteristics and structures on to its offspring. And then the opposite happens too. If you have unfavorable phenotypes, then really the environment is saying, you're not right for us. Super sorry. It's you, not me. Sorry, but you're going to be dead soon. I mean, it's not like Mother Nature is saying, I don't like that phenotype. Instead, it's saying, here's the environment we have, and you don't have the right physical structures to survive, thrive, and reproduce. The result is you're about to die off. You saw an example that was similar to this in this set of notes, right? Like, in this particular case, you've got mice, a population of mice with different phenotypes, right? Different body structures. Some have white fur, others have gray fur. Well, guess what? There's predators in this environment too. Guess what the predators are going to pick out first? The mice that are white, because they're easier to spot and easier to find. The result is that phenotype is being naturally selected right out of nature. White mice, not as common in the natural world. The natural world is saying, if you're white, you're going to stand out. That phenotype doesn't work. You have an unhelpful variation. And the result is that variation isn't going to be passed down to succeeding generations. It doesn't mean all white mice will be gone. Some white mice will still be around. But you're going to find far more gray mice. The population of gray mice will grow. Why? Because it's a helpful variation. It helps the mice to blend into their environment so they're less likely to be the target of predators. And if they're less likely to be the target of predators, they're more likely to survive. If they survive, they reproduce. And when they reproduce, they pass that helpful variation down to their offspring. Is this making sense to you? So this is part of that idea of evolution. It's part of change over time. How does change happen over time? Well, some animals have beneficial mutations or variations. And those beneficial mutations and variations, those phenotypes that work, those body structures that are positive get passed down, and the body structures that are not positive don't get passed down. Now, I got one more question for you to think about, and it's a question that I won't answer for you, but that we'll talk about in class. Are you ready? Here is the question. Scientists believe that when there is more variability in a population, that population is more likely to survive, through periods of environmental challenges. Sounds really fancy, but here's what that means. If there are lots of different kinds of mice, to use the previous example, if there are multiple different shades of mice, if there's brown mice and gray mice and white mice, and maybe dark brown and dark gray and dark white, I don't know if that's a thing or not, but if there's lots of variation within the mouse population, then scientists would argue that you've got greater diversity. Greater diversity means more types of. And when you have more types of phenotypes within a population, the population is more likely to survive when there are times of environmental challenge or when there are times of environmental change. Do you think that's true? Would greater diversity, which means more variations within a population, would that help you to survive environmental challenge or environmental change? And if so, why? All right, I can't wait to hear your answers. We'll talk more about that in class. Bye, guys.